Hello and welcome in to my Physics Online video series. Today's video we're going to be doing a walkthrough of the Ohm's Law lab that I use for the Physics 2 courses. So we will walk through the lab briefly along with some calculations. As always, you should have already, before watching this video, read through the lab handout instructions. So you've already read through all these directions. Not that there's that many directions. It's literally one page this week, not even a full page. So you should have already done this before coming to this video, as I've said. What you do is you need to launch the PhET simulation. Hit the play button. Instructions, basically straightforward. Essentially what you are doing is you are creating a voltage versus current graph. Basically you are measuring the voltage drop across the resistor as a function of the current through the resistor. You are doing this for 9 total voltage values, and then you're basically going to repeat this after doing it for the first resistor with 2 other resistors. Then you make a plot. So let's pull all that up. First, you're told to set the resistance to 100 ohms, to 500 ohms, and to 1,000 ohms. So again, if you have read through these directions, you know that you're doing this at all 3 of these values, 100, 500, 1,000. The default value here, I've not touched anything yet, is 500 ohms. So there's not really any point here in doing the 100 first. You might as well just do the 500 first and save yourself the trouble of trying to get it back to 500. You basically are going to be controlling the voltage here, and then it tells you down here what is the current. And so you should be basically making yourself a little data table that has on it voltage, and then you can make a table that basically has current. You can do it in milliamps or amps, but you should break this into maybe 3 subcategories. So you'd have subcategory 1 would be for resistor R equals 100 ohms. The next one would be R equals 500 ohms. And the last one would be R equals 1,000 ohms. All right, so your table basically looks like this. And then you'd want to maybe make like a little sub-tabling in here, like so. And then your voltage settings, you're supposed to do 1, 2, 3, 4, 5, 6, 7, 8, and 9. So basically you're filling up this table that I've created here with these different voltage and current values. Voltage, of course, is in volts, current, milliamps. So for example, like this first entry, this is 1 volt, this is 500 ohms, it says 2.0 milliamps. So the first entry that I'd be putting into my table, I'm just going to swap over colors for entering. So this would be 2. Okay, and then you come back to this thing, you change your voltage to say 2 volts, and then you write down the value that you get. And you just fill out the whole table, etc., etc., and etc. Next step, using graph paper, or computer plotter. That would be like Excel, LibreOffice, Calc, or whatever else, Octave, MATLAB, Desmos, etc. Python. Whichever thing you like to use, you're going to make a graph. Graph basically just looks like this. The axes for your graph, excuse me, axes for the graph say current and voltage. You want to put all three onto a single plot, okay? And you can kind of choose what you're going to put on which axis. I think the natural way to look at it is that I was directly controlling the voltage of the batteries in volts, and therefore my independent variable was that. My dependent variable was my current. You might want to convert these currents to amps before plotting. You could plot them in milliamps, but you may want to convert them to amps first, because you should be getting a set of lines. And so let's kind of like draw a set of lines, or curves or what have you. So you get your plot. You have to make it yourself a key. So you could label it like this, depending on what order stuff is going in. It might be like this, for example, or it may be the other way around. And probably actually I should go ahead and put the labels in whatever color the line is in. So, maybe it looks like this. Maybe these are reversed order. Whatever it is you've got, they should be labeled. They should all be on one plot. One of them will look awfully close to this axis. The other one may look awfully close to this axis for the points chosen. That's all right. You have to analyze them. It's always the same analysis, so analyze these. That means get the slope and intercept. And then, look at the units. Look at units. Oops. Of slope and intercept. And you're comparing to Ohm's law. So what does Ohm's law say? Ohm's law says delta V is I times R for a excuse me, for an ohmic resistor. This could also be cast as I is equal to delta V over R. Or if you'd prefer, this is 1 over R times delta V plus 0. This you could also say is IR plus 0, whatever. You should be looking at these equations. These are Ohm's law 2 versions. Look at these two equations and compare them to what you actually got on this graph, okay? So once you've done that, you're kind of like turning in the graph, turning in this analysis, and then you're supposed to have a little discussion of whether the graph agrees with Ohm's law or not. That's it. That is this whole lab. It's meant to be relatively short, relatively easy. If you were doing this lab on campus, like this class on campus, most campuses, including both that I've taught this or an equivalent course on, you would have this lab more or less the way that I've just shown it. But you'd have like an actual resistor and maybe a power supply with an adjustable knob for voltage, and maybe an actual like voltmeter. It usually ends up being probably the shortest, fastest lab or one of them that we end up doing for most classes. So that trend kind of continues here. So hopefully this little walkthrough was worth it for you, and best of luck to all of you who are doing this.